Picture this, a space with absolutely nothing in it, right in front of you. The air removed, the light blocked, every trace of matter erased. So does true nothingness actually remain? In 1948, physicist Casimir derived something extraordinary. Place two metal plates in a high vacuum, and the effects of the quantum electromagnetic field will cause them to attract each other. The source of that force is energy dwelling within the vacuum itself. Here's what quantum mechanics reveals, and it's deeply unsettling. Empty space does not exist. No matter how void a region appears, energy continues to fluctuate within it. So what exactly is nothingness? That's the question we'll venture deep into today. By the time this video ends, the meaning of every space you once called empty will have shifted at its foundation. Chapter 1. The Illusion of Empty Space. From childhood, we were taught something we never thought to question. Remove the air, and you have a vacuum. A vacuum is a state of nothingness. But as physics matured, this intuition began to crack. Can a true state of nothingness actually exist? In 1927, Heisenberg unveiled the uncertainty principle. It is impossible to simultaneously know both the position and momentum of a particle with perfect precision. This is not a limitation of our instruments. It is a fundamental law of nature. And this principle carries a remarkable consequence. In confined quantum systems, even at the ground state, complete stillness is forbidden. A fluctuation called zero-point motion persists without end. Within the quantum vacuum, field fluctuations arise ceaselessly, conceptualized in calculations as virtual particles. Virtual particles cannot be directly observed, yet these vacuum fluctuations exert real influence on reality. The Lamb shift, a subtle displacement in hydrogen's energy levels, and the Casimir effect have both been confirmed in precision experiments. In other words, empty space does not exist. What we call a vacuum is, in truth, filled with invisible fluctuations. Consider this for a moment. The airless space you sense right now, in this very room, is roiling like a storm at the quantum level. What appears most empty may be the most abundant place of all. So how does this vacuum energy manifest in the physical world? But the real mystery begins here. Let's look at how the forces generated by the quantum vacuum were observed in the laboratory. Chapter 2. The Casimir effect. Force born from nothing. If the vacuum holds energy, it must influence something. That evidence is the Casimir effect. Do you know what happens when metal surfaces are brought within a few hundred nanometers to a few micrometers of each other in a high vacuum? The space between them, containing nothing, begins pulling the plates together. In 1997, physicist Lamoureux succeeded in measuring this force with extraordinary precision, capturing the world's attention. The mechanism works like this. On the outer sides of the two plates, quantum fluctuations of every size exist freely. But in the narrow space between the plates, only fluctuations of specific sizes can exist. This asymmetry generates a pressure that pushes the plates inward from the outside. In other words, a space that should contain nothing is moving metal plates as a real, measurable force. This has been repeatedly confirmed in experiments accounting for corrections in material properties, temperature, and more. And there's an even more astonishing experiment. In 2011, researchers succeeded in generating actual photons, particles of light, from the vacuum by oscillating a boundary at high speed within it. Known as the dynamical Casimir effect, this phenomenon demonstrates that the vacuum is not mere emptiness, but a field from which real particles can be drawn through manipulation. Creating something from nothing, this is not a metaphor. This is a fact, confirmed in a laboratory. Let's think about what this means. If all the empty space across the entire universe is filled with this fluctuating energy, what is the magnitude of that total? A naive theoretical calculation yields a discrepancy with the observed value of up to around 10 to the power of 120 orders of magnitude, known as the cosmological constant problem. The exact figure shifts depending on the assumptions, but by any measure this is the greatest divergence between theory and observation in the history of science. And in 2024, the latest cosmic observation project, DESI, began suggesting that this vacuum energy may itself be changing over time. Even the assumption that vacuum energy is constant has started to waver. The mystery only deepens. The energy held within empty space is bound up with the fate of the entire universe. And we still do not understand its true nature. So what does this reality mean? Let's take a wider view and explore how the concept of nothingness reshapes the human vision of existence. Chapter 3. A universe born from nothing. The meaning of existence. If the quantum vacuum is not absolute nothingness, a profound question emerges. Is it possible that the universe itself was born from these quantum fluctuations? Philosophers have asked for thousands of years, why is there something rather than nothing? And that question still has no definitive answer. Inflation theory tells us that the seeds of structure in the early universe, the faint irregularities from which galaxies and stars were born, originated in quantum fluctuations. This has been rigorously tested against observational data from the Planck satellite. The stars we look up at tonight may be quantum fluctuations from the universe's first moments, grown to cosmic scale. At the same time, the claim that the universe originated from a vacuum depends on models like quantum cosmology, and no single answer has yet emerged. But the question itself remains alive, at the very boundary between science and philosophy. Philosophical nihilism holds that absolute nothingness underlies everything. Yet, at minimum, the vacuum of quantum field theory is the lowest energy state, a fundamentally different thing from the philosophical concept of nothing. The vacuum contains fluctuations. It cannot be called truly empty. This is not merely a matter of physics. It means our deepest intuition about nothingness is being called into question at its roots. I want to pause here and consider. If the quantum field vacuum is never truly still, never absolutely nothing, how natural is it, really, for existence to arise in this universe? If every space that appears empty is fluctuating, perhaps the universe is always striving to give birth to something. What I feel most deeply is this. Humanity searched for nothingness, and everywhere it dug, it found only something. Existence did not defeat nothingness. Nothingness never made it to the arena. Today's exploration leaves us with a kind of humility. What we call empty may be the most complex thing of all. And what we call existence may need to be questioned all over again. Let's bring together what this exploration has revealed. Chapter 4. New questions about reality. Today we ventured deep into the question of what nothingness truly is. The empty space we took for granted simply does not exist. The quantum vacuum is filled with fluctuations that generate real force through the Casimir effect, and through the dynamical Casimir effect, actual photons have been confirmed to emerge from the vacuum itself. And the, quote, philosophical nothingness of the vacuum is fundamentally distinct from the vacuum that quantum field theory describes. Let me share 3 insights from today's exploration. First, space that appears empty is filled with quantum fluctuations. Field fluctuations produce measurable effects, the Lamb shift, the Casimir effect, and through the dynamical Casimir effect, real photons have been generated directly from the vacuum. The invisible exists as a real force. Second, the vacuum in quantum field theory is the lowest energy state, fundamentally different from the philosophical concept of absolute nothingness. The vacuum is a non-trivial state that contains fluctuations. It is not empty. We need to question what we mean when we use the word nothing. Third, inflation theory holds that the seeds of large-scale cosmic structure originated in quantum fluctuations, an account supported by Planck satellite observations. The stars we look up at may be the grown form of quantum fluctuations from the dawn of time. When these 3 converge, a single great shift becomes visible. Humanity searched for nothingness and found only the richness of existence. Fluctuations do not cease. The vacuum is not empty. The universe stands upon fluctuation. I'll be honest, sitting with this again, I feel a quiet astonishment. The airless space, right where you're sitting now, is fluctuating ceaselessly at the quantum level. And the latest observations from 2024 suggest that vacuum energy may itself be changing over time. The mystery only deepens. I find that a beautiful fact. Here's what I want to ask you. If the quantum vacuum is always fluctuating, if absolute nothingness cannot exist, is existence itself an inevitability of this universe? And if your own existence is built upon this fluctuating energy, does the meaning of being here shift for you? Science does not yet hold a complete answer to these questions, but it is the act of asking that moves us forward. The exploration never ends, and that is precisely what makes it worth pursuing. After this video, when you return to the ordinary world, try to hold this awareness just for a moment. The next time you sense an empty space, a bare room, the night sky, a still surface of water, pause. It is filled with invisible quantum fluctuations. The place that looks most empty may be the most complex of all. Knowledge is what changes how we see the world. If your sense of emptiness has shifted even slightly from today, that is the meaning of today's journey. Share your insights in the comments below. Your questions are what drive this channel forward. Thank you for staying with me on this intellectual journey all the way to the end. On this channel, where we explore the nature of the cosmos, consciousness, and existence, we'll keep pursuing questions like today's, where science and philosophy converge. If you want to discover the astonishment hidden behind what we take for granted, subscribe and turn on notifications so you don't miss the next journey. Until next time,